Hey everyone, and welcome to this explainer. If you're passionate about fitness and optimizing your body, you already know protein is absolutely essential. But today, we're skipping the locker room rumors. We're going to dive straight into modern clinical data to dismantle some of the most pervasive dietary bro science out there.
You know the drill. We've all heard the warnings, right? Eat too much protein at once and you're just flushing expensive nutrients down the drain. Or even worse, that you're somehow destroying your kidneys or leaching calcium right out of your bones. Well, today, we are putting all of those fears under the microscope.
All right, here is our roadmap for today. We're going to cover the 30-gram limit, kidneys and high protein, the bone demineralization myth, plant versus animal proteins, aging and muscle loss, and finally, we'll wrap up with your ultimate protein playbook. Let's get right into it.
Okay, Section 1, the 30-gram protein limit, myth versus reality.
For decades, sports nutrition guidelines told us that we could really only absorb about 20 to 30 grams of protein in a single sitting, and that anything extra was basically just wasted. But this old rule mistakenly relied on just one single metric, muscle protein synthesis, or MPS. The problem is, that's only half the equation. The new rule focuses on whole body net protein balance, and that is protein synthesis minus protein breakdown. So while synthesis might plateau at those lower doses, taking in larger doses actually aggressively suppresses whole body protein breakdown. That means your overall net gain just keeps going up.
There's this fascinating research from the Tromelin study that really drives this home. Researchers used a highly advanced quadruple isotope tracer to track exactly where protein goes inside the human body. They compared a standard 25-gram dose to a massive 100-gram dose. And the results? That 100-gram dose was absolutely not oxidized or wasted. Instead, it resulted in continuous amino acid availability in the blood over a 12-hour period. This drove a massive 40% increase in late-phase muscle protein synthesis compared to the smaller dose. It's a real game-changer.
So yeah, you can breathe a sigh of relief. You aren't flushing your expensive protein down the drain. You really need to think of your gut less like a leaky pipe and way more like a brilliant, slow-release reservoir. When you eat a large, mixed meal that has fats and fibers alongside that protein, your digestive tract simply hits the brakes. It steadily releases those amino acids into your bloodstream over many, many hours.
Moving right along to Section 2, kidneys and high-protein diets.
So, when you eat a lot of protein, your kidneys naturally increase their filtration rate. This is a process called glomerular hyperfiltration. For a long time, doctors worried this meant the kidneys were being totally overworked. But here is the crucial takeaway. This hyperfiltration is actually a completely healthy evolutionary adaptation. It's just your kidneys using their natural functional reserve to process those amino acids. It is absolutely not a sign of toxicity or impending damage in healthy individuals.
To put this into perspective, we can look at the clinical data from the OmniHeart feeding trial. They fed healthy adults a diet where 25% of their total calories came from protein, and after 6 weeks, their estimated glomerular filtration rate safely increased by about 4 milliliters per minute. This was a perfectly safe adaptation, and it was completely independent of blood pressure.
However, context is literally everything in biology. While high protein is perfectly safe and even protective for healthy kidneys, it is a very different story if you have pre-existing chronic kidney disease. For compromised nephrons, that increased blood flow acts as a destructive mechanical shear stress, and that can actually accelerate renal decline. So the bottom line is, if your kidneys are healthy, protein is great. But if you have CKD, you definitely must follow clinical restrictions.
All right, Section 3, the bone demineralization myth.
Have you ever heard the wild claim that meat makes your blood acidic and that it forces your bones to literally dissolve themselves just to neutralize the acid? This is known as the acid-ash hypothesis. It used to be widely taught, but modern clinical research has totally debunked it. The theory wrongly claimed that because we see more calcium in our urine after eating protein, it meant our bones were actively dissolving. Actually, far from dissolving your skeleton, protein is incredibly protective. Data from the massive E3N cohort study showed that as long as your baseline calcium intake is adequate, meaning over 800 milligrams a day, higher protein intake is highly synergistic with bone health. Get this, it actually reduces the risk of a hip fracture by an astounding 85%. That is huge.
So you might be wondering, where is that extra calcium in the urine coming from, if not from the bones? Well, dual isotope tracer studies revealed the fascinating real mechanism. Dietary protein dramatically boosts how much calcium your intestines absorb from your food. We're talking by up to 42%. Your body simply excretes the extra calcium it just absorbed. Systemic pH barely even changes. The only time protein poses any risk to your bones is if your diet is basically void of calcium to begin with.
Next up, Section 4, Plant versus Animal Proteins.
When it comes to protein quality, the absolute modern gold standard for measuring it is the DIAS scoring method. This looks at how well we actually digest essential amino acids. Animal proteins, like skim milk powder, score incredibly high. Plant proteins, on the other hand, often score lower. This is due to limiting amino acids and fibrous matrices that kind of shield the protein from our digestive enzymes. Because of this, if you're relying entirely on plant proteins, you generally just need to eat a larger total volume or carefully blend your sources to match the muscle-building efficiency of animal protein.
Section 5. Aging and Anabolic Resistance.
As we get older, our skeletal muscle develops something called anabolic resistance. Basically, older muscles get a bit stubborn and they blunt their response to amino acids. So while a young adult can trigger maximum muscle synthesis with just around 20 grams of protein, an older adult needs a massive spike of leucine to trigger the mTOC1 signaling pathway. They very often require 35 to 40 grams of high-quality protein per meal just to turn the system on and fight off age-related muscle loss, which is known as sarcopenia.
And finally, Section 6, the Ultimate Protein Playbook.
If you only remember one single number from this entire explainer, make it this one. Consuming between 1.6 to 2.2 grams of protein per kilogram of body weight every single day is the absolute gold standard. This is the sweet spot for optimizing muscle growth, preserving your metabolic rate, and supporting overall health. Hitting this daily total vastly outweighs how frequently you eat or exactly when you time your meals. Total intake is king.
Now, once you're consistently hitting that total daily target, you can level up and optimize further with what we call protein pacing. You simply divide that total into 4 to 6 meals containing about 20 to 40 grams of protein and space them out every 3 to 4 hours. Looking for an extra edge? Consuming 30 to 40 grams of a slow-digesting protein, like casein, right before sleep is a fantastic way to maximize your overnight recovery.
So, the science is absolutely clear here. When paired with adequate calcium and healthy kidneys, high-protein diets aren't just safe, they are powerfully protective. Your gut is totally ready to handle what you give it. Knowing the true limits of human absorption, you've really got to ask yourself, is your current diet truly fueling your potential? Or are you still holding yourself back based on debunked locker room myths? Take this science, apply it to your plate, and go optimize your health.